The highest power from the denominator is root x squared. But we know that root of x squared, it is equal absolute value of x. Because root of x squared, it will be either x if x greater than or equal to 0, or minus x if x less than 0. So we'll divide all the function by root of x squared. So now we have f of x will be equal 5x over root x squared divided by root of x squared plus 4. We will divide also by root of x squared. So now 5x over root of x squared, we said that root of x squared, it is just absolute value of x. So 5x over root of x divided by, this one will remain the same, over root x squared. So now we'll take 5x over absolute value of x divided by root of x squared plus 4 over root of x squared. It will be root of x squared over x squared. So here we will have x squared plus 4 over x squared. X squared over x squared will be 1 plus 4 over x squared. It will be 4 over x squared and all under the root. So now we need to consider the limit when x approach to infinity and the limit when x approach to minus infinity. If x approach to infinity, we will take the absolute value of x. When x greater than 0, we'll take it x. So it will be 5x divided by x over root 1 plus 4 over x squared. So x will cancel with x, just we have limit of 5 when x approach to infinity. And here we have limit of 1 plus 4 over x squared when x approach to infinity. Limit of 5 will be 5, and here we have 1 plus 4 over infinity. We said if you divide any number by infinity or minus infinity, the result will be 0. So limit of 4 over x squared will be 0. So 1 plus 0, it will be 1. So now we have 5 over 1, which is equal 5. So y is equal 5 is a horizontal asymptote as x approach to infinity. Now let us see the limit of fx when x approach to minus infinity. For the minus infinity, we will take the negative sign for absolute value of x. So this will be 5x over minus x over 1 plus 4 over x squared. We will do the same step, we will get it is equal minus 5. So y is equal 5 is a horizontal asymptote, and y is equal minus 5 is also a horizontal asymptote for our function f of x. يعني هنا لما نجي نشوف الدالة هنا عبارة ما نقدر ناخذ الأكبر أس من البسط وأكبر أس من المقام. قلنا يصير إذا كان عندي بولينوميال وبولينوميال، لكن بما أنه عندي دالة جذرية إذا هنا على طول آخذ أكبر أس موجود في المقام. فأكبر أس موجود في المقام هي عبارة عن root of x squared. نعرف أن root of x squared عبارة عن absolute value of x نعرفها x و minus x. x لما الx أكبر من الصفر وminus x لما الx less than 0. بعدين بنقسم الدالة كامل على root of x squared بسط ومقام. طبعا لما نجي ناخذ الليمت لما الx approach to infinity ناخذ الابسولوت value of x بالموجب يطلع الناتج آخر شيء 5. لما ناخذ الليمت لما الx approach to minus infinity ناخذ اللي هي الابسولوت value بالنيجاتيف يطلع عندي minus 5. إذا ال 5 horizontal asymptote وال minus 5 also a horizontal asymptote. So example number 9, evaluate limit of x square minus root of x power 4 plus 7x square plus 1 when x approach to infinity. Here if you direct substitute you will get infinity minus infinity, but you cannot say that infinity minus infinity it is equal to 0 because infinity it is unknown. Also you cannot take the highest power here because this one it is not polynomial. So the trick for this one, you will multiply by root, you multiply your function by x squared plus root of x power 4 plus 7x squared plus 1, and you will divide by the same value which is x squared plus root of x power 4 plus 7x squared plus 1. So once you multiply by the conjugate, then you simplify your function. X squared multiplied by x squared will be x power 4. And this root with this root will cancel. We left with minus x power 4 plus 7x squared plus 1. And here 1 multiplied by this term, it will be the same term. Now you can cancel x power 4 with minus x power 4. You will left with limit minus 7x squared minus 1 over x squared plus the square root of x power 4 plus 7x squared plus 1. Again here also you cannot take the highest power from the numerator and you cannot take the highest power from the denominator. So you will divide by the highest power in the denominator. The highest power here we have x squared and here we have the root of x power 4. So we'll divide by the square root of x power 4. We'll divide numerator, we'll divide the denominator. So square root of x power 4 will be x squared. So we'll divide our function by the square root of x power 4, whole function by this term. So we said that the square root of x power 4 it is just x squared. So minus 7x squared over the square root of x power 4 it will be minus 7. And here we'll have minus 1 over, you can write it like root of x power 4 or x squared. And from here we have x squared divided by x squared, it will be 1 plus, then x power 4 plus 7x squared plus 1 divided by the square root of x power 4. We'll take it under the same root. X power 4 over x power 4 will be 1. 7x squared over x power 4 will be 7 over x squared plus 1 over x power 4 will be 1 over x power 4. Now if you distribute the limit for the numerator and distribute the limit for the denominator. For this one we have limit of minus 7 minus 1 over x squared. The limit of 1 over x squared when x approaches to infinity it will be 0. So from the numerator just we left with minus 7. From here limit of 1 plus limit of 1 plus 7 over x squared plus 1 over x power 4 under this root. So limit of 1 will be 1. This 7 over x squared will give us 0. 1 over x power 4 will give us 0. So 1 plus from here 1 it will be 2. So the final result will be minus 7 over 2. So y is equal minus 7 over 2 is a horizontal asymptote. So for our function here we have it is x squared minus square root of x power 4 plus 7x squared plus 1. This one is an even function because if you substitute with negative you will get the same function. And the limit when x approaches to infinity, when x approaches to minus infinity it will be the same. First we multiply by the conjugate، يعني أول شيء نضرب في المرافق لأن ما نقدر ناخذ هنا أكبر أس، لأنه أكبر أس لو أخذنا أكبر أس هنا ما هذا ما بولينوميال، هذا فيه عدد قدري. على أساس ناخذ نفس الشيء أكبر أس من المقام فأول شيء لازم نسوي rationalize للنيوميريتر. فالrationalize معناته نضرب في المرافق. ضربنا في المرافق يطلع لنا هذا الفانكشن، بسطناها يطلع لنا الفانكشن minus 7x squared minus 1 over this term. بعدين بنشوف إيش أكبر أس موجود في المقام. هنا عندي x squared وهنا عندي square root of x power 4. طبعا هنا x squared لكن هنا square root of x power 4 نفس الشيء بيكون من الدرجة الثانية. فدائما لما يكون كذا ناخذ اللي موجود تحت الجذر، إذا كان يعني درجة اللي برا الجذر نفس درجة اللي مع الجذر، فناخذ اللي هي square root of x power 4. نعرف إن square root of x power 4 عبارة عن x squared، معناته أقسم الدالة كامل على x power 2 أو square root of x power 4. فبقسم البسط وبقسم نفس الشيء المقام. بعد ما قسمنا طبعا نبسط الدالة، باخذ الليمت للبسط وباخذ الليمت للمقام. أي عدد عندي مقسوم على x وأجيب الليمت لما الx approach to infinity على طول الناتج يعطيني 0. فهنا الليمت 0، الليمت هذا 0، الليمت هذا 0. إذا اللي يتبقى عندي إيش؟ minus 7 ومن هنا عندي 1 ومن هنا 1. minus 7 over 1 plus 1 which is minus 7 over 2. إذا y is equal minus 7 over 2 is a horizontal asymptote. So when you work with a function containing the natural exponential function, the following four limits merit special attention. So here we have a graph of y is equal e of x, w1, and y is equal e of minus x, which is the red one. If you want to evaluate the limit when x approaches to infinity or minus infinity. So let us see first y is equal exponential of x. So if x approaches to minus infinity, so that's mean you go to the x-axis, x approaches to minus infinity, the value of the limit will be equal to 0. So limit exponential of x when x approaches to minus infinity, it will be 0. When x approach to plus infinity, so x goes to this direction, the value of your y goes to this direction, which is goes to infinity. So limit of ex when x approach to infinity, it will be infinity. Now let us say the function y is equal exponential of minus x. When x approach to infinity, the value of your graph approach to 0. So limit of exponential of minus x when x approach to infinity, this will be equal 0. And when x approach to minus infinity, the value of your graph goes to infinity. So limit of exponential of minus x when x approach to minus infinity, it will be infinity. So we see here, limit of exponential of x when x approach to infinity, it will be infinity. Limit of exponential of x when x approach to minus infinity, it will be 0. Limit of exponential of x when x approach to infinity, it will be 0. Limit of exponential of x when x approach to minus infinity, it will be infinity. طبعا أحيانا بدخل نحن نتلخبط بينهم، أي واحدة منهم 0 أي واحدة منهم infinity. أسهل طريقة نحفظ الرسمة. الرسمة هذه عبارة عن exponential of x، والرسمة هذه عبارة عن exponential of minus x. إذا حفظنا الرسمة نقدر على أساس نحدد أي واحدة منهم لما الأكس approach to infinity تعطيني 0، وأي واحدة منهم تعطيني infinity، والعكس صحيح. فلو حفظنا الرسمة سهل على طول نرسم الرسمة ونتذكر منها أي واحدة منهم تعطي 0 وأي واحدة منهم تعطي infinity. فبنلاحظ إنه هنا ال y is equal to 0 horizontal asymptote، لأنه هنا لما الأكس approach to infinity الناتج يطلع لنا 0. إذا ال y is equal exponential of minus x هذا horizontal asymptote when x is equal 0. نفس الشيء ال y is equal to 0 horizontal asymptote للفانكشن y is equal exponential of x، لأنه limit of exponential of x when x approach to minus infinity يطلع لنا 0. إذا بثنتينتهم هذا horizontal asymptote لما ال x is equal 0. And here we have example number 10. Determine whether the graph of f(x) is equal 6 over 1 plus exponential of x has any horizontal asymptote. So for this one we will find the limit when x approach to infinity and the limit when x approach to minus infinity. So limit of 6 over 1 plus exponential of minus infinity, we can distribute the limit. It will be limit of 6 over limit of 1 plus exponential of minus x. 6 is constant, so it will be 6 over. Limit of 1 will be the constant 1. Limit of exponential of minus x when x approach to infinity. So we said here, limit of exponential of minus x when x approach to infinity, it is equal 0. So this value will be 0. So 6 over 1 plus 0, it will be 6. So here, since we have a number, we conclude y is equal 6 is a horizontal asymptote. Now also we need to see what is the limit when x approach to minus infinity. So it will be limit of 6 over 1 plus exponential of minus x when x approach to minus infinity. If we do the same step, we'll see that limit of exponential of minus x when x approach to minus infinity, which is this one, the result it will be infinity. So here you cannot distribute the limit because here you will divide by infinity. So 6 over 1 plus infinity, it will be 6 over infinity, which is 0. So therefore, y is equal 0 is a horizontal asymptote. So we conclude that this function has two horizontal asymptotes. y is equal 0 and y is equal 6. يعني هنا على أساس نحدد ال horizontal asymptote قلنا لازم نجيب الليمت لما ال x approach to infinity ولما ال x approach to minus infinity. لما ال x approach to infinity وزعنا الليمت يطلع لنا 6 over 1 limit of exponential of minus x لما ال x approach to infinity is 0. So 6 over 1 plus 0 will be 6. إذا عندنا horizontal asymptote and ال y is equal 6. هنا عندنا 6 over 1 plus exponential of minus x بنجيب الليمت لما ال x approach to minus infinity. نلاحظ إنه limit of exponential of minus x لما ال x approach to minus infinity يطلع عندي infinity. أساس كذا في الخطوة هنا ما وزعنا الليمت، عوضنا تعويض مباشر يطلع عندنا 6 over 1 plus اللي هي infinity. قلنا أي عدد أقسم على infinity يطلع الناتج 0. إذا 6 over infinity الناتج يطلع لنا 0. إذا y is equal to 0 is a horizontal asymptote.